So I'm going to be explaining some of the concepts that we are supposed to know in Physics 191, starting from the first part of it. So if there is time, I'm going to make sure I record video for the other parts also. Now the first aspect of Physics 191 that we are going to be looking at is graphical methods. Now for graphical methods, there are some concepts that we are supposed to know before we deal with graphical methods. Now we are supposed to know what is a constant. What do you call a constant? A constant is just a quantity with a fixed value. A constant, you always have a fixed value. What do you mean by that? That means that the value can never change. That means that numbers are constants. Numbers like 1, 2, 3, 400, 1 million, they are all constants. There are very many constants in physics, like pi is a constant, 3.142 till infinity. E is a constant, 2.718 till infinity. G is a constant, G is also a constant. So all these values are constants, and the reason we call them constants is because they cannot change. Now, what about variables? Now, variables are those quantities that they don't have fixed values, they change. So any quantity that changes, we are going to be calling it a variable. We have an example of that. The force is an example of a variable. The mass is an example of a variable, because they change for different objects. No, not everyone on earth can exert the same force. Not everyone has the same mass. Not everyone has the same mass. So stuff like that, they are variables because they can change. Unless you are not talking about a fixed object, that's when the mass can be constant. For example, the mass of the earth, there is a fixed value for the mass of the earth and other objects also. But in general, anything that can assume any value, we call it a variable. But most commonly in mathematics, the most common variables in mathematics are x and y. So that's why when you are given equations to solve, you are like find the values of x and y, solve the following simultaneous equation for x and y. Although they use other variables too, but the most common variables that they use are what? X and y. Now, apart from knowing that variables that they change, there are other stuffs that we're also supposed to know about variables. Now, we're supposed to know that for variables, they can be splitted into two. A variable can be independent and it can be dependent. Now, what's the difference between these two? Now, when a variable is independent, what it means is that it can assume any value. Let me put it that way. It assumes any value. So a variable that is independent is going to assume any value it likes, and the value is not affected by the value of other variables. That's when it is independent. From the word independent, that means that it can stand on its own. But when they say that a variable is dependent, that means it can't just assume any value, and its value depends on the value of another variable. That's when a variable is going to be dependent. That means that you can't just give it any value you like. It is the value of a variable that determines its own value. Now let's consider an ideal situation of a father and child. of a father and child. Now let's talk about the father's salary as a variable, and let's talk about the child's pocket money as another variable. Now, which one is dependent, which one is independent? Now, the child's pocket money depends on the father's salary, but the father's salary does not depend on the child's pocket money. So that means that the father can the child's pocket money depends on the salary that the man is collecting. So that means that if the child is collecting a very small pocket money, it must have meant that his father is collecting a small salary. And if the child is collecting a huge amount of money, it must have been that the father is collecting a large salary. So that means that whatever pocket money that the child is going to collect will depend on the salary, but the salary of the father does not depend on the pocket money of the child. So what we are just trying to say in essence is that if the father is having a huge salary, we like feel more need to give the child more out of his money, and if he's collecting a very small salary, it's going to be a small amount of money that is going to give the child. But the father's salary does not depend on the pocket money. It is the pocket money that depends on the salary. So what this means is that once the father's salary changes, the pocket money will be affected. Once the father's salary changes, the pocket money of the child will be affected. But if the pocket money of the child changes, that does not necessarily mean the father's salary is going to increase or decrease, because the child might also have additional sources that is also getting money from. So let's just try to get the concept here. So if the father's salary is much, the pocket money will be much. If the father's salary is small, the pocket money will be small. But if the pocket money is much, doesn't necessarily mean the salary is much. It might be that he's getting additional money from other sources. So that's just the concept of what dependent variable and independent variable. And it's very common that in physics, when you want to do an experiment, you are going to be given a particular variable. For example, when you are doing an experiment of simple pendulum, they use lengths of maybe 20 centimeter, 30 centimeter, 40 centimeter, 50 centimeter. Look at that, they just give you these lengths independently. That means that the length can assume any value it likes. So all these ones that you are given are independent variables, because they stand on their own. Now what are you going to be asked to do during the process of the experiment? You are going to be asked to find the period. Now the period, you can't just write any values for the period. You have to do the experiments, use these values for length, then determine what the values of the period will be. So that means that the period cannot just assume any value. It depends on what length you use that will determine what the period is going to be. So that means that period here is what? A dependent variable, while length is what? Independent. So this is another way to identify which variable is dependent, which variable is independent from the experiments that you are given, and from the values that you are given. Let's assume that you are asked to perform an experiment where you are to measure the increase in length. And if you have to measure the increase in length, what are you going to be given? They will give you different masses. They say use masses of 20 gram, 30 gram, 40 gram, 50 gram. What does this mean? They are giving you the masses independently. So that means that the mass here is what? The independent variable, because that's what you are given. It doesn't depend on any. I didn't mean that it depended on something. They would have given you. So, but you are now to determine the values of what? Of the extension. So that means that the extension depends on the mass. Whatever you put for the mass will determine what the extension is going to be. So that's another way to identify which variable is dependent and which variable is independent. So I think we are done with dependent variables and independent variables, and mostly in mathematics, we usually represent dependent variables with y and independent variables with x. So you read this as what? Y is a function of x, meaning that what? Your x is independent while your y is dependent, meaning that if they say y is a function of x, what it means that what? Y depends on x, but that does not necessarily mean that x depends on y. So when you say y is f of x, it means that what? The value of y depends on what value you use for your x. So that is simply what it means. So then in physics, you also perform experiments, just as I have said. Now your experiments can be asked to look for the relationship between variables. You might be looking for the relationship between variables. The relationship between variables. And you might also be measuring the value of a constant. Or you might even be doing both together. For example, in an experiment, simple pendulum, you are given length, you are asked to measure the period, and then you'll be asked to plot the graph, and from the graph determine the value of g. So you are given length, you are determining the period. That's what? Relationship between two variables. Then you measure the value of g, which is what? A constant. So your experiment can come in various formats, but that is always how the experiment always look. Now whenever you perform an experiment, you are given a list of what? Independent variables. Then from that list of independent variables, you are supposed to do the experiment and get a list of dependent variables. After getting this list of dependent variables, you might be required to show these things that you have gotten. You might be required to show them visually, like to show those things that you have gotten visually. Now, how do you visualize results? It is when it comes to the concept of visualizing results that you are going to need a graph. There are many ways of visualizing results actually. In mathematics, you can use what is called, you can use a graph. In maths, you can use a pie chart. In maths, you can use bar chart. You can use any form of chart to visualize your results. But in physics, the most popular way of visualizing results is by the use of graphs. The most popular way is to use graphs to visualize them. So let's assume that in this experiment you are given values of length in meters. We have maybe in centimeters. We have 20 centimeter, we have 30 centimeter, we have 40 centimeter, 60 and 70 centimeters. Then after we have done the experiment, we now got different values of length. We got different values of period. So let's say the first one, we got the period to be maybe 0.9. We did the second one, we got the period to be maybe 1.1. We did the third one, we have maybe 1.3. The next one, we have 1.4. The next one, we have 1.6, and the next one we have 70. So let's say we have 1.7. So these are the values that we obtained when we did the experiment and we measured the period. Now we are now going to be asked to show these values, like we should show them, visualize this, and that's when we are going to need a graph. So when you plot this on a graph, it's possible that your graph, by the time you plot these points, they are going to be straight, and it's also possible that when you plot this point, your graph is going to be a curve instead of a straight line. So this is what is going to lead us to the concept of graphs. Now, a graph is just like a grid. A grid means where you have a vertical axis and a horizontal axis, and your vertical axis you have your y, which is what your dependent variable, and your horizontal axis you have your x, which is your independent variable. Then you have to plot points and connect them. So which means that it's possible that, let's assume that we have 1 2 3 4 5 6 7 8. So you have 1 2 3 4 5. So let's say you're going to have a table for x and y. Let's say we have 1 2 3 4 5. Now I have 2 4 6 8 10. So that means when x is 1, y is 2. When x is 1, y is 2. That's this first point. When x is 2, y is 4. When x is 2, y is 4. This second point. Now these ones are 1 2 3 4 5 6 7 8. These ones are 2 4 6 8 10, like that. So when x is 3, y is 6. When x is 3, y is 6. Although you are not going to draw these lines, you are just going to be locating them. So you have something like this. So then you connect the points after you have located all the points. So this is how you plot a graph. Now it's possible that your graph is straight like this one, and it's possible that you have a curve. It's also possible that your graph is going to be a curve. That means you have something like this. Let's say you have something like this, then you have something like this, then you have something like this. You can't join these points with a straight line. You join them with what? A curve, something like this. So it is now curved instead of being straight. So your graph can look anyhow, but the most common graphs that we have in physics are always straight line graphs. Now, please don't forget that we are always plotting graph of what? Y against x, which is what? Dependent variable against the independent variable. But sometimes they might change it. It might be the graph of independent against dependent, but that does not mean that it will be a graph of x against y. So whatever you have on the what you have on the vertical axis can flip. That means that on the vertical axis, instead of putting the dependent, they can put independent, but it will still be y. Then instead of putting independent here, they can put dependent, but it's still going to be x. So I think we are done with that. Now let's talk about some of the properties of a straight line. Now for any straight line, a straight line is always going to have, what do you call it? A straight line is always going to have a what you call a slope. A straight line is going to have what you call a slope, and it's also going to have what you call, now this is a typical graph paper. So let's assume that this is my y axis and this is my x axis. This is my x axis, and let's say we have two lines. So this is the first line and this is the second line. And compare these two lines. Even though both of them are passing through the same points, they don't look alike. If you look at this is more bent than this one. So this goes up more than this one goes up. So that means that the two lines are having different slopes. So slope is what? A very important property of a straight line, and the slope is like how bent your line is. Usually define slope as rise over run. So how high does your line travel, and how horizontal, how forward your line also travels. If you look at this, it covers more height than it covers horizontally, but this one covers less height than it covers horizontally. So that means that our first line is more slopey than the second line, and slopes usually represent slope with what? With m. Okay, so that's for slope. Then another property that a straight line is going to have is what we call the intercept. Now the intercept of your straight line is where your straight line is cutting the y-axis and also the x-axis, where it cuts the vertical axis and also where it cuts the horizontal axis. And these two values are like very important, but they represent both of them differently. So where it cuts the horizontal axis is the x-intercept. Look at that. At this point you have your x-intercept, and where it cuts the vertical axis is the y-intercept. So at this point you have your y-intercept. Now the one that is most important is the y-intercept, and we represent it as c. So we represent our y-intercept as c. So because where it cuts the vertical axis, you will know the value, so automatically that means that your c is a constant. And also where it cuts and also your straight line has a fixed slope, so automatically your m is also a constant. So that means that any straight line will have a constant slope, and it's also going to have a constant vertical intercept. It's going to have a constant slope and it's going to have a constant vertical intercept. So those are the two most important properties of a straight line that we must know. Now let's think of how can we calculate the slope of a straight line. No, we just explained that the slope of a straight line is just the rise divided by the run. So let's assume that we have a straight line that goes this way. I want to find the slope of the line. How can we do that? So these are y and this is our x. So let's assume that we have values 1, 2, 3, 4, 5, 6, and here we have values of 2, 4, 6, 8, 10. And if you want to find the slope of your straight line, we just explain that it's rise over run. Now rise is how high it is, that is your change in y. That's rise is what is going up, that means it's traveling along y. Then run is how forward it goes, that means it's traveling along x. So your slope will be y2 minus y1 divided by x2 minus x1. Now for you to do that, you pick any points that you like on your graph. Now you can come and pick this point because it's on the line, and you can also pick this point that is also on the line. Now what's going to be the slope of our line? What will be the slope of our line? And the slope of our line is going to be, what is y2? This is the first point, this is the second point. So that means that our y2 is going to be, you trace it here, you trace it to the vertical to know the value of y. That will be 6 minus our y1 is, you come to this first point, that's 2, divided by our x2, you still come back to this point, that's 3, minus our x1, you trace it down horizontally, that's 0. So that means that our slope is what? 4 over 3, which is 1.33. Now it doesn't matter, since we have said it is constant, you can pick any point you like and you still get the same value for the slope. So that means that if you like, you could have chosen let's see which other point you could have chosen this point and choose it with this second point. So that means that, let's assume that these are the new points that we have chosen. So this will now be 0.1, this will be 0.2. So at this point, what's going to be the value of y? Now look at that, this is interesting. Y is, it looks like it's a decimal, right? It looks like it's having a decimal value. That's like from 8 to 10, that's 2. Now you divide it into 10 equal parts. 2 divided by 10 is 0.2. So that means this is 8.1. That means this will be 8.1, 8.2, 8.3. So that means that the value of y here is going to be 8.3. and the value of y here is 6, while the value of x is 5. So let's see if this is going to work. So it's going to be y2 minus y1. So the value of y here is, sorry, it's not 8.3. So this is 8 points. We said we have 10 boxes and it is 2 units. That's another thing I supposed to talk about. From here to here is 2, right? That's 10 minus 8, which is 2. Then you divide it into 10 because you have 10 boxes. So 2 divided by 10 is 0.2. So each box is 0.2. So this is, if here is 8, so we have 8.2, 8.4, 8.6. So you're going to have 8.6 minus y1. That means you come to this point. Your y1 is 6. Divided by, what's your x2? You come down. Your x2 is 5 minus your x1, 3. So let's hope it gives us a similar answer. So 8.6 minus 6 is 2.6, divided by 5 minus 3 is 2. Now this is also what, 1.3. Look at that. So it's still approximately the same answer that we are getting. So that shows us that no matter what points you pick, as long as there are points on your line, you will continue to get the same answer. So that is how we find the slope of a straight line. But it's not very important since you are no longer doing your practicals. What we just need is how is going to help us out during the process of the exam. So I think that is all done. Then we need to talk about the equation of a straight line. Now, talking about the equation of a straight line, the equation of a straight line, we write it as what? Y equals mx plus c, where m, we have already talked about it, that is the slope, and c is what? The intercept on the vertical axis. That means where your line cut across the vertical axis, that's what's going to be the value of your c. So, and if you plot a graph and it is already a straight line, then you have no problem because it already resembles this. For example, let's say that we have now let's talk a little bit about this equation. Now you see that we have our variables, which are x and y. Now look at your x, your y. The things you notice about y is that its power is 1, and also it has no coefficients. If you look at your x, its power is also 1, but it has coefficients. And the coefficient is the slope. Then there is this one that doesn't have, that is just a constant. There is no variable attached to it. That's how all equations of straight line are supposed to look. For example, if somebody told me that they plot a graph of two variables p and q, they now give me the equation as p equals 3q plus 5. This equation is an equation of a straight line. Why? Because look at p, it has no coefficient, the power is 1. Look at q, it has a coefficient, the power is 1. And look at this, no variables at all. So I can boldly say that this is going to be the slope and this is going to be the intercept on the vertical axis. It doesn't matter that they have changed the variables to p and q, the results will still be the same thing. But if somebody told me that his own equation is p is equal to 3q squared plus 11, this is no longer the equation of a straight line. Why? Because the value, the power, although this is having no coefficient and its power is 1, this is having coefficient, but the power is no longer 1. So this changes this from equation of a straight line to equation of a curve. And it still has, although it still looks like it's having intercept, but it is no longer a straight line since it does not completely look like y equals mx plus c. So I think that should be should take note of that. Now, how do we make these equations? How do we turn them to equations of straight line? That means that you are given a particular equation and you want to turn it to equation of a straight line. That's now where the concept of